Hello dear students, I am Chaman from JNB RCCAT Khwai, Tripura. Alright, in this video we will study collisions, the last part of the unit 4 of your syllabus. Alright, we have already studied what is meant by conservative force and the law of conservation of mechanical energy we have already studied. In this video we will study what do we mean by collisions. Alright, what are different kinds of collisions, what are the physical and mathematical conditions to be a particular kind of collisions, and what are the physical implications of it. All these things will be discussed. Okay, so generally before we get into the physics of collisions, let's understand it in a simple way. All right, collisions means we generally think that the striking of two bodies. Generally we see two vehicles getting colliding with each other, or two balls colliding with each other. All right, so we will understand it mathematically and what is the physics involved in these collisions. Okay, so here comes the first slide. All right, so collisions. Okay, here comes the definition. Okay, a collision is said to take place between two bodies if they collide with each other, or the path of one is affected by the force exerted by the other. Okay, see it carefully. The definition goes like this: a collision is said to take place between two bodies if they collide with each other physically, or the path of one is affected by the force exerted by the other. Okay, like two magnetic poles, or if two magnets will bring closer or throw them up, if their poles are exact same, they will repel each other, they will not strike with each other, something like that. Okay, so here is a point: the physical contact between two bodies is not necessary for a collision to occur. All right, every time physical collision is not necessary. All right, see in these pictures, so this is a collision. Here there is a physical contact. All right, two vehicles colliding with each other. Here are two celestial bodies colliding with each other. Okay, this is also a kind of collision. All right, but see here, this is the Rutherford's alpha particle scattering experiment. You might have studied in the 9th or 10th standard. Okay, this is the discovery of nucleus, Rutherford's atomic model. All right, so here the coming alpha particle, the alpha particle doesn't touch the nucleus. There is no physical contact, but there is a deflection in its path. All right, so and this deflection is because of the force of this nucleus. So this is also a collision, because its initial path, the initial path of the alpha particle, is affected by another particle, another nucleus. So this is also a kind of collision. So different kind, all these three are examples of different collisions. So this is the general view of collision. In the next slide we will see what are different kinds of collisions. All right, here they come. Okay, types and characteristics of collisions. All right, first of all comes the elastic collision. Okay, if there is no loss of kinetic energy during a collision, it is called an elastic collision. All right, so what happens if there is no loss of kinetic energy? Okay, remember what is the only condition? The kinetic energy has to be conserved. The kinetic energy should be constant, it should not change. All right, this is the condition of elastic collision. All right, so what are the characteristics of this kind of collision? The moment of energy are conserved. What are conserved? Momentum and energy are conserved. The kinetic energy is also conserved. The forces involved only conservative forces. So what kind of forces act generally here? Only conservative forces are acting in elastic collisions. Okay, this is an important point. Only conservative forces to act. All right, the mechanical energy is not converted into any other form of energy. All right, like when generally two bodies collide, there is sound energy, there is light energy. Okay, there are different kinds of energy conversions, but in elastic collision there is no such conversion. Only the total energy is conserved. Okay, the kinetic energy is also conserved. So this is, and what is the example of this? The collision between subatomic particles. Okay, in macroscopic scale it doesn't happen, it only happens in subatomic particles. Here in this diagram, this is LHC, Large Hadron Collider. Here, the experiment of, subatomic particles are carried out, in which subatomic particles are allowed to collide with each other, and their impact is, measured. Okay, so this is the example of elastic collision. Now comes inelastic collision. Okay, here what happens, let us see. If there is no loss of if there is loss of kinetic energy during a collision, it is called inelastic collision. If there is a loss of kinetic energy, okay, generally, what are the characteristics? Momentum and energy are conserved. Okay, these are universal rules, and momentum and energy are always conserved. Whether it is elastic or inelastic collision, these two things are always conserved, but the kinetic energy is not conserved here. All right, what does it mean? Not conserved means kinetic energy will be converted into some other kinds of energy. All right, the forces involved are non-conservative. Why non-conservative forces have to be here? Because the kinetic energy is not conserved. Okay, if kinetic energy would have been conserved, then it would have been an elastic collision. A part of this kinetic energy is converted into other form of energy, as I've already said. Okay, what are the examples? Is collisions of automobiles and ball hitting a cricket bat or something like that. Okay, so the elastic collision only occurs at the subatomic level. All right, but beyond that, for in microscopic scale, the collision becomes inelastic. All right. Now see some other kinds of collisions. Okay, this one is important. Perfectly inelastic collision. Okay, what is perfectly inelastic collision? Here what happens when two bodies collide with each other. After the collision, the bodies stick together. All right, the bodies stick together and move as a single body. Okay, so this is the speciality of this kind of collision. All right, if two bodies stick together and move as one body after collision, then it is called a perfectly elastic collision. All right, like mud thrown on a wall stick to the wall. Okay, all right, this is an example of a perfectly inelastic collision. Then there is one more kind of collision. It is head-on or one-dimensional collision. Here what happens? If the colliding bodies move along the same straight line path before and after collision, it is called head-on or one-dimensional collision. Suppose imagine the two compartments, both are on the railway track, and suppose they have a collision, then they will move along the railway track only. Okay, means their path will not be changed. So this is what an example of head-on or one-dimensional collision. What happens here? The initial and final path of the particles do not change. They move along the same straight line. Then two-dimensional collision. All right, here what happens? There is a change in the path of the colliding bodies. All right, generally this collision is mostly we see two-dimensional collision, because after collision their paths generally change. So the collision of carom coins, while playing caroms, when the coins strike with each other, what happens? Their paths change. All right, so these are different kinds of collisions and their characteristics. So what are the characteristics? In elastic collision, all kinds of conservation law is valid there. Well, momentum energy are conserved, kinetic energy is conserved, but in inelastic collision, all are conserved, but kinetic energy is not conserved. Why not conserved? Because that kinetic energy is converted to some other kinds of energy. All right, next comes perfectly inelastic collision. Here what happens? Two bodies stick together after collision, and they move as a single body. All right, head-on or one-dimensional collision. Here what happens? That the path of the colliding particles or colliding bodies do not change, and in two-dimensional collision, the paths are changed. So these are different kinds of collision and their characteristics. All right. So now we'll see the mathematical derivation of elastic collision in one dimension. Okay, so what we are studying now, elastic collision in one dimension. Okay, I have already mentioned that in one dimension what happens? They move in the same path, okay, before and after the collision. And in an elastic collision, here what happens? The kinetic energy is conserved, momentum and energy are conserved, and the kinetic energy is also conserved. So we will derive an expression for the final velocities of the two bodies, okay, after collision, that we will derive. All right, so what we have to do is look at this diagram. So these are two bodies, M1 and M2 have taken, all right? M1 and M2, these are two bodies we have taken, and they both are moving in the same direction with initial velocities u1 and u2 respectively. Okay, M1 was moving with a velocity of u1, and M2 was moving with a velocity of u2, and such that what are the condition we have taken? Initially u1 is greater than u2, means the first body is moving at a speed greater than the second body. So what will happen after some times? Definitely m1 will collide with m2. Obviously the first body will collide with the second body here. Because why they will collide? Because this one is moving with a greater velocity. So this is the collision that took place here. All right, m1 strike with m2. Then what happened? The velocities eventually changed. u1 became now v1 and u2 became now v2. So this is the condition. All right, now let's understand what is the physics involved here, what is the mathematical involvements here. All right, so for any kind of system, the linear momentum is conserved, okay, as we know already. So initially and finally, the total momentum will be conserved, okay. M1 U1 plus M2 U2. These two make the total momentum before collision, all right. And M1 V1 plus M2 V2, these two make the total momentum after collision, all right. So this is according to the law of conservation of momentum, all right. So let's put this equation 1. So what we will do, I will bring this quantity to the left side, and this quantity will be taken to right side, and I will take common m1, right? So m1 into u1 minus v1 will be m2 into v2 minus u1. So this is our equation 1, all right. So this, from where we got it? We got this equation 1 the from the law of conservation of momentum, all right. Now see the next one. Since the kinetic energy is also conserved, as it is an elastic collision, so kinetic energy must be conserved, all right. So conserved means what? Before and after collision, the total kinetic energy is same. So before collision, this is the total kinetic energy, half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. So these two make the total kinetic energy before collision. These two make the total kinetic energy after collision. So now there is also some mathematical conversion here. I have taken this term to left side and this term to right side. So on on separating it and simplifying this, we will get u1 plus b1, u1 minus v1, m2 into v2 plus u2, and v2 minus u2. Now this is your equation 2. This one came from the law of conservation of kinetic energy from elastic collision. This is the condition of elastic collision, and this is a universal condition. The total momentum is always conserved. So from equation 1 and 2, if I'll divide these two, what I will get? I will get u1 plus v1 is equal to v2 plus u2. See this. These things will be cancelling with each other, and we are left with how much? u1 plus v1 and v2 plus u2, all right, or u1 minus u2 is equal to v2 minus v1. So this is what we mathematically got. So what is the physics involved here? Okay, u1 minus u2 means the relative velocity before collision, okay, and v2 minus v1 is the relative velocity after collision. Relative velocity means how much speed a body has in excess than the other body. This is called relative velocity. So from this mathematical derivation, what we got, the relative velocity before collision is equal to the relative velocity after collision. Okay, so this one is important. So what is the what is the conclusion here? The relative velocity of approach, means before collision, is equal to relative velocity of separation, all right. u1 minus u2 is equal to v2 minus v1, and this condition is very important, and where it happens? Only in elastic collision, all right. So this is how the initial and final velocities are related. This is how the initial and final velocities are related. Now we'll see what will be the value of the final velocities. Okay, remember this equation 3, u1 minus u2 is equal to v2 minus p1. u1 minus u2 is equal to v2 minus p1. Okay, now we'll see what will be the velocities of the body after collision. All right. So we've seen that the velocity of approach, the relative velocity of approach is equal to the relative velocity of separation from the mathematical derivations we got. All right. So u1 minus u2 will be v2 minus v1. All right. And v2 will be how much? u1 minus u2 plus v1. So what we have to do is we will use this v2 in the law of conservation of momentum. All right, in the first equation one, m1 u1 plus m2 u2, this is the initial momentum and this is the final momentum, and instead of v2 we will use this value u1 minus u2 plus v1. All right, so on putting, so okay, we have already put here. All right, now what in this step what we have done, we have separated the terms that contains m1 to the left and that contains m2 to the right. So this is what happened. All right, and we have multiplied them. All right, after multiplication we got terms like this. All right, now what we have to do, okay, we have taken b1 common here. All right, so why we have separated b1? Because we want b1. All right, we are deriving the value of v1. All right, so b1 will be how much? So b1 you will get like this, u1, okay, in u1 into m1 minus m2 over m1 plus m2 plus 2 m2 u2 divided by m1 plus m2. All right, and from the value of b1 here, okay, if we'll find the value of v1 first, then put here, you will get the value of v2. All right, so by this method you can find out the final velocities after an elastic collision. All right, in one dimension. So in this video we have discussed what are the different kinds of collision, and we have also mathematically derived the conclusion of one dimensional elastic collision and what are its velocities before and after collision. All right, so this is for this video. All right, and in the later videos we will see what are two-dimensional collisions and what are the coefficient of restitutions. Okay, you will see in the next classes. Thank you.